This video will be a brief review of how to identify similar figures when given the side lengths. As we've talked about in class already, two figures are similar if the ratio of the corresponding or the matching sides is proportional and all of the corresponding angles also have to be equal. So let's see what that looks like with this example. We're given two triangles and we're asked if they are similar. So the first thing I always like to do is I like to highlight my corresponding sides. So I can see that 8 corresponds with 12, or matches up with 12, and 10 corresponds to 15. The next thing I'll do is I'm going to write a proportion with those corresponding sides. So I'm going to take the short side, or the height of the small triangle, over the height of the large triangle, and see if that equals the base of the small triangle over the base of the large triangle. So I'm lining up those matching or those corresponding sides. Okay, well there's a couple ways we could check to see if these are equal, but we're trying to figure out is 8/12 equal to 10/15. So one way we could do it is to just maybe simplify both fractions. 8/12 is equal to, let's see, they're both divisible by 4. So 8 divided by 4 is 2, and 12 divided by 4 is 3. So that's that fraction or that ratio reduced to 2/3. And 10/15, well, these are both divisible by 5, and I end up with 2/3 as well. So since the ratio of our corresponding sides is equal, that shows that these are similar figures. And I didn't mention this before, but we're going to just assume that all of our angles are equal for this example. Another way that we could have shown that these are equal is I could have done something like this. I could have said, well, what's 12 divided by 8? If I take 12 divided by 8, I get 1.5. So that means that 12 divided by 1.5 would give me 8, or my bottom divided by my top is 1.8. I could do the same over here and do 15 divided by 10, and when I do that, I also get 1.5. So that's telling me to go from the bottom to the top. I divide by 1.5. Since it's the same thing on both sides, I didn't really highlight that very well here, but since it's the same thing on both sides, it's more proof that it's proportional. Okay, and kind of a final way I guess you could check it would be you could just multiply your diagonals. If they equal each other, we know that that proportion is true, which again tells us then that those are similar figures. 12 times 10 is 120. 15 times 8 is 120. Since they equal each other, we know again, yes, this proportion is true, so these are proportional ratios. Therefore, yes, these are similar figures. So lots of different ways you can check it. You'll only be required to show one of them that you find the most useful. Okay, let's try one more example. This one says, are these rectangles similar? Show how you decided. So again, I like to start by highlighting my corresponding sides. I see that I have 4 and 2, so I'm just going to write 4 over 2. And we're trying to see if that equals, I'm going to go back to the big one now, 5 over 3. Okay, so I did the top on the big one over the top of the small one, left of the big one, left of the small one. Okay, we could have set this up another way, that would have been okay, but we're just going to work with this right now. Okay, so now to test if these are proportional, one thing I can see right away is if I do, to get from 4 to 2, I'm dividing by 2. But to get from 5 to 3, well, if I do 5 divided by 3, I get 1.6 repeating. So that means I had to divide this by 1.6 repeating to get to 3. Since 2 does not equal 1.6 repeating, right? We divided by different numbers to get that bottom. These are not proportional. Okay, another way I can show it here, 2 times 5 is 10, 3 times 4 is 12. 12 does not equal 4, or 12 does not equal 10, so this is not proportional. Okay. Hopefully this will be enough to get you started on what you need to do for today. If you're still kind of confused, feel free to go to the Bayview Math website and type in similar figures, in the search box, and you will get a lot more options and things to look at there as well. Otherwise, we can talk when I get back tomorrow.